for your systems. And Jim Steele's talk yesterday was standing room only, in fact, sitting room only. That was really nice to see that. I hope that session will be repeated. My name is Peter Williams. I'm a technical specialist for SNOMED International. Been working there since 2013. And I have 40 slides to get through today. There's 40 minutes, so if we get through it too fast, maybe I'll sing a song, but we'll see. Maybe please do interrupt me as we go. If the question's too complex, maybe we'll leave it to the other side. This is a two-parter, so we'll go through this session, then we'll have a coffee break, and then there's a practical exercise after that. How many people were at Jim's talk yesterday? Okay, about half the room. And did anyone make Redmond in June? Was anyone there for that talk? Daniel, you were there? Yeah. Okay. So hopefully you haven't seen too much of this material before. SNOMED International started in 2007, coming out of the College of American Pathologists, who decided that terminology was a difficult thing. It takes a lot of time and money to put together. And so they formed SNOMED International as a not-for-profit organization. In fact, we were called the International Health Standards Dissemination Organization, IHTSDO, at the time. And nobody could really say that. You could attempt to say ITSIDO, but generally we had to revert to NATO phonetic spelling to explain who we were. And so since we only make SNOMED CT, we have renamed the company as SNOMED International. And we're working with HL7 here. We run the two companies jointly run our call on a Tuesday night. Well, it's my Tuesday night. It's a nice time of day for the Americans, and it's very early in the morning for anyone in Australia. Good morning, Graham. And we call that SNOMED on FHIR, and really we're there for the benefit of members, and if anyone wants to join that call, you're very welcome. We discuss anything that people have of interest. And we split into two streams. We do terminology binding 1 week, and then on the next week we'll do terminology services. And Rob Housenham is my co-chair on that call, so we work together on that. So SNOMED is like having a dictionary that tells you what words mean. And unlike a dictionary, everything only has one definition. So we're unambiguous, and we know exactly what we're talking about. It's self-describing. Everything you need in that dictionary is part of the dictionary itself. But it doesn't tell you how to write a haiku, how to lay out a screenplay, or draw up a contract or anything like that. So we need an information model, and that's where FHIR comes in. So SNOMED is the terminology, tells you what to put into the information model, the electronic health record, the message, whatever you're working with. And FHIR is the information model in this case. SNOMED is an ontology. It has logical underpinnings. There's a lot of material out there. You could go to the SNOMED International website for information about why SNOMED's great. I'll say it's a comprehensive multilingual healthcare terminology. It's curated by clinicians. It's been developed for the use of clinicians in medical health records. It's scientifically validated, and we use a classifier to infer relationships. So we have relationships from concepts to other concepts, which we'll cover in a minute. And we use a classifier to tell us relationships we might have missed. And in fact, we use it to maintain the whole structure of SNOMED. The classifier does all the heavy lifting for us. And it also does logical checks, so we can see things like equivalences when we have two concepts that are the same. Doesn't spot them in every case, but if we've properly defined a concept, two concepts to be the same, then we'll get warned about that. And we map to other international standards, ICD 9 and 10. So we're going to look at SNOMED CT components, concepts, descriptions, and relationships, and more. This is part of the foundation course that SNOMED International offer. That's a 3-month course, so we'll be going through that in about 10 minutes, which is a lot of compression. SNOMED consists of concepts, descriptions, and relationships. We also have localization mechanisms, language reference sets to allow you to express your electronic health records in most languages. SNOMED International issues the international version of SNOMED, and then we have national release centers in various countries that add local content that are specific to those countries. So we'll talk about that a little bit. And we have a concept model that tells you how concepts can be put together. So for each particular area of SNOMED, we have a machine-readable concept model, which is, can be computed, that says what attributes can these concepts have. And that ensures that anyone who's building SNOMED for themselves, if they follow that, then their concepts will classify correctly and appear at the right point in the hierarchy. So we'll have a look at concepts first. Concept is the primary thing in SNOMED. Everything is a concept. A concept has a unique identifier, and when you see a SNOMED code, this is what you'll see. It's an integer. Sometimes it's a very big integer. As a programmer, we store those as longs, which I really like personally because I can store them very cheaply in sets. I can do manipulations. I could get the whole transitive closure, all the relationships that exist into memory at the same time, and ask very quick questions about does this thing subsume that thing? Is it one of those, or what are all of my ancestors? And that's really quick to do. So it's what the SCT ID, the integer, that's set in stone, and that doesn't change for the lifetime of the concept. Neither does ideally, we never change the fully specified name either. That's a unique term for that concept. And we add a thing called a semantic tag at the end of the FSN, which tells you exactly what hierarchy it's part of. So there's no ambiguity there. Because terms can be ambiguous, because clinicians use the same term in many places. We'll see an example of that in a little bit. So if we're going to change the FSN, the fully specified name, we would usually inactivate that concept and create a new concept in its place with a new identifier. DefSNs are unique for all active terms. It could be that we have a historical inactive concept with the same FSN, but no active concept will have the same fully specified name. Moving on to description. So a fully specified name is a type of description. We'll also have a preferred term, so all concepts will have at least a fully specified name and one synonym. I mentioned the semantic tag to ensure that we're unique there. And we can have any number of synonyms used by patients or clinicians. Only one term will be considered preferred, and the other ones will be acceptable for a given language or dialect, or perhaps even a community. Patient-friendly terms, as an example, it can be quite confusing when we say we have a language reference set for patient-friendly terms. It's nothing really to do with your language or dialect, but it is a community that has a set of terms that they prefer to use. And we have other description types. We've actually been discussing adding some more, but you can have a definition as well, which has is potentially much larger in size, up to over 1,000 characters. And we can get some text in there. Right, I was talking about whether descriptions are acceptable for a given dialect. In the international edition, the FSN is always in US English. We also publish a language reference set for British English, and those have, sometimes they have, most of the time we have the same word, but occasionally we have a different term for the UK. And then the various countries have their extensions, and they will specify a preferred term in their own language. Spanish is interesting. They've chosen to, TermEd that we were working with at the time they were doing our release for us, they decided to translate the fully specified name as well. They're the only country that's chosen to do that, though the only group that have chosen to do that, because translation is a very expensive thing to do. There's a $1 cost for every term that gets translated, and as new concepts come into SNOMED, someone has to spend quite a lot of money getting that translated into each language. But something like Danish will have its own term. It can have other synonyms. A point that's made about translation is not to translate all of the English synonyms, but just to take the fully specified name or the preferred term, translate that, and then see what other synonyms might exist in your language, which is the correct way to do it, not to try and translate every synonym, because they're synonyms, so they all do mean the same thing in the end. We see an interesting thing when we translate languages, that when you try and translate a concept, sometimes in a different language, the concept turns out to have the same name. This happens in Spanish, and you say, well, what is the difference between to hear and to listen? And at that point, we get into a big discussion about language, and sometimes it turns out there is no difference, and in fact, we only need one concept. So the translation can be a really good quality control method in itself. Terms themselves don't have to be unique. Clinicians use, when they come across a great word, they'll use it anywhere. Fundus is a fun one. It means the part of a thing that's opposite the opening. So that could be in a uterus, could be in the eye. Where else are we using it? In the gallbladder. So that's a synonym, which doesn't have to be unique, but the fully specified name always will be. We'll say exactly where that is. So this is why SNOMED can be complex to use, and why it's very important in a user interface that you tighten it down and say, where exactly am I talking? You would have maybe a reference set, some sort of subset for the particular clinical specialty you're interested in. So someone who was working in ophthalmology wouldn't see these other funduses. You'd say, well, I'm working on the eye, so I know what part of the body I'm talking about. So when a clinician types in fundus, they would see the one that's relevant to them. But that doesn't happen for free. You would need to, as developers, we would need to think about that sort of thing. All right. Concepts have relationships. Every concept, not every concept, almost every concept is related to other concepts through two types of relationships. Well, they're all relationships, but we have the ISA, which means I'm a subtype. I'm one of those things. So everything that's true for my parent is true for me. If my parent has any attributes or properties, they're true for me as well. And we have the attributes, which vary according to where we are in SNOMED. Looking at the ISA relationship first. SNOMED is a polyhierarchy. It reflects the real world, so a thing can be a type of many other things at the same time. So an appendectomy can be both an operation on the appendix and a partial excision of the large intestine. And this is how it is in life. This is how clinicians think. So, for example, I am human, I'm male, I'm Scottish, I'm all of these things all at the same time. It's amazing. And you could ask for all the people who are Scottish, and SNOMED, if we modelled such thing in SNOMED, we'd be able to answer those questions and ask for the conjunction of those things. So give me every Scot male, every human, all at the same time. And that's what that looks like for appendectomy. Just those first two parents. I'm an operation on appendix and a partial excision of large intestine. Those have their parents. So on above them, I think there's about 37. All the way up. And all these things are true, and everything that's true of those ancestors is true of appendectomy. All the way up to procedure and SNOMED CT concept, which is the interesting one. SNOMED CT concept is the only concept that doesn't have any source relationships, which occasionally throws me when I'm writing a query. And then the first level down from there, the immediate children, there are 19 of those, and we call them top-level hierarchies, so procedure is one of our top levels. Other interesting ones are body structure, clinical finding, medicinal product. Okay. So that was ISAs. ISA is a transitive tree, so we'll always work from any given concept. You'll be able to trace your way all the way up to the top. And that's usually a special case. There are other transitive relationships, like part of, if you say, oh, fingernail is part of my finger, is part of my hand, you'll always get up to body structure working transitively as well. So you could say that there's a hierarchical relationship for those as well. And there's a lot of work being done in the body structure hierarchy. We're changing the model there to allow part ofs. They have existed in the past, but they're going to be a little more complete in the coming years. So attributes, we have attributes for concepts, and depending on what it is, we have the machine readable concept model. I mentioned will tell you what attributes you can use for a given domain. So appendectomy has a method. It is an excision and a procedure site of appendix structure. And this allows us to do analysis, to write queries on concepts and patients for given things without necessarily knowing what concepts we're interested in. We could just say, well, give me everything that's associated with the appendix, whether it's a procedure or a diagnosis, and then we could form a reference set for people who are interested in specifically in the appendix. You probably need to do some curation on that afterwards, but it would be a starting point. So putting those together, what do I know about appendectomy? I know what its parents are, that it's an ISA, and I know its method and its procedure site. And when we ship SNOMED CT, that turns into a flat table of all the concepts, how they're related to all the other concepts. And that's quite a dense format. It's just the SCT ID and the relationships file. SNOMED CT was designed many years ago when we cared about space, and the file structure is quite terse, quite complex. And that can be loaded into relational database tables, which is one way of querying it. A lot of people are now working with NoSQL methods. Our own server uses Elasticsearch, and we store things more as objects, more like JSON. Oh, these are defining relationships. A defining relationship is always true, which sort of influences the philosophy of SNOMED. We don't say how things should be used. We don't say what they're useful for. You don't get that sort of medical information. We just say these things are always true, and they're defining. And sometimes we say that these things are sufficiently defined so that anything else with these properties must be one of these things. So if you have an excision and an appendix structure, then you must be an appendectomy. And this is how a classifier works. It takes things that you've stated to be true and sufficiently true and says, well, if you've got one of those, you must be one of these, and it tells you a bunch of things that you didn't know before. I do love a good class diagram. Everything in SNOMED is a component, and although we haven't shown it here, reference set entries are components as well. Every component will have an ID and effective time, might be active or inactive, and it belongs to a module. So a concept, we said, must have at least 2 descriptions. And on the other side, it can take part in a relationship in a tuple in any one of 3 ways. It could be the source, and we've said it was one-to-many, but in fact the root concept would not play in a source relationship. It could be in a destination, although it doesn't have to. It could be a leaf node, in which case it might not have any, so it's 0-many there. And it may or may not be an attribute type in its own right. I think that covers that. So that inheritance, I love doing that in Java. That means that some of my code's shorter, because I can call things components and see if the effective times have changed, check for things going inactive. Well, I make use of that. Right, reference sets. Reference sets are a SNOMED thing. They are literally a set of references with a varying level of detail. If they are just a reference, if the reference set just contains SNOMED concepts, then we'd call that a simple reference set, which is a sort of subset, which is a sort of value set. Or we can add another column, which might be the target of a map, and we can add further details still. The ICD-10 map, for example, is a complex map, And although you have a number of targets for a given SNOMED concept, there's also some rules around it. So you might say, well, we map to this ICD-10 code if the patient is female, but we map to a different one if they're male. And that information is not available in SNOMED, so we can't do that mapping for you. That information has to be determined at runtime before you can safely do a mapping, which ICD-9 didn't have that problem. It was a simpler case, but with ICD-10, there isn't an automatic answer for mapping between SNOMED and ICD-10. A value set in this context is a FHIR thing. It's a new thing for SNOMED International to talk about value sets, but we've come around to the idea that they are just subsets. It's a collection of concepts that you put together for some purpose. A reference set, being part of SNOMED, has a formal structure to it. And if you wanted to publish a reference set, you'd need to have a concept that represents that reference set. And to publish a concept, you need a namespace. You need to be able to create an SCT ID. So there's a bit of overhead to that. A value set, much cheaper thing to publish. You could, if you've got a URL, you could, or even if you don't, you could make one up, and you could publish a value set. And a subset is a general term. It's not specific to either SNOMED or to FHIR, and you could just put a collection of things into a spreadsheet, into a text file. An example of that is the global patient set, which SNOMED International has published recently. This is for companies that don't have a SNOMED CT license. We've made these concepts freely available for use, and we tried to move away from RF2 and that formalism, and we've just said there's a TSV file with the codes you need and the terms. And it's not even versioned, but hopefully that will allow people to do some development work, and maybe they'll get access to a full SNOMED CT release at some point in the future. Hi.
Value set and subset, is that essentially the same thing? No, I don't really get the difference.
As what they are, yes, they're the same thing. It's a subset of components, but we're talking in a FHIR context. A value set is a resource that has a specific format. But yeah, both HL7 and SNOMED International would say a value set has a wider existence than that. When we talk about a value set, it doesn't have to be a FHIR value set or a SNOMED value set. And the nice thing about value sets is you can mix and match your code systems within them, whereas reference sets would, no, it must be a SNOMED concept in those. Right. So that was basically the foundation course, a 3-month course, which we've compressed into 20 minutes. Any questions on that? We'll have time for questions at the end, hopefully. Right, terminology services and operations. Jim covered this fairly well. Jim was in the room. Hi. Jim covered this well yesterday, so we may have some overlap there, but we'll look at concept maps, code systems, and value sets. SNOMED, of course, appears in the other resources, just not all of them, but in many places where there is a value set, it could take a SNOMED concept. But that's fairly straightforward. In a condition, for example, you'll have a SNOMED code that's a clinical finding, procedures. The use of SNOMED there is fairly straightforward. This is the more interesting section for us. SNOMED International's terminology server, we're not really storing patient data in there. We are concerned with terminology, so we don't look at those other resources yet. Although it'd be great to do medication. I've got that down on my resource list to expose the medicinal products from SNOMED as medicinal resources from FHIR. Code system resource, we can run a number of operations on that. We can validate the code, check that it's part of the code system. We can test it for subsumption. Is this thing, code A type of code B, or the other way around? And we can do a lookup on a code and give me more detail about it. So there's the URLs for that. This is the URI for SNOMED. I want a particular code, and you might say, need the format to be JSON or XML. This is more fun. We can ask for the normal form. There are a number of properties there. There's a web page for SNOMED CT on the HL7 website that lists the properties for SNOMED, and the normal form is one of them, and that allows you to see all the relationships. Actually, we construct a SNOMED expression, which is quite a tight way of describing a concept. Concept map, translation between one code system and another, or so in the first case, we've said here's my code that I'm interested in, my source in that system. My source is SNOMED CT, my target is ICD-10, and there's the particular map that we're interested in. It's an intrinsic quality of that URL. So that's the ICD-10 map. And that can give you more than one answer back. I was talking about the different rules that might apply. So you'll see more than one thing, and unfortunately, FHIR doesn't allow us to say what those rules are. So if you were going to do this, then FHIR is a starting point, but if you need those rules, you'll need to find another way to get that information. And here's an example of mapping within the same code system. So we'll go from a SNOMED concept to another one, and the map there is the same as historical association, which is when we've inactivated a concept, we'll say this is what we've replaced it by, or maybe it's ambiguous. These are the 2 or 3 concepts that it might be that it might have an equivalence. Expand is my favorite operation. There's a number of things you can do with it. These parameters become part of the URL that you pass through. FHIR VS, that's all SNOMED concepts. We can use an ISA and say, give me all concepts that are one of these that are subsumed, all my children and descendants. FHIR VS equals ref set by itself is quite interesting. That will give you a list of all reference sets that exist in your terminology server. Not sure why you'd want to do that, but you can certainly find them. We have an ongoing piece of work to provide metadata for reference sets, because generally you have to know what they are and what they're used for and what they're going to contain before you start using them. But we hope to make that computable in the future. So more likely you'll specify a reference set and say, give me all the concepts in there, which you could then filter by some text that you're interested in, and you could ask for the descriptions to be in a particular language. So there are some examples of that. In the first one, we use an ISA, say, give me all of my descendants. In the next one, we say, can I have that in Spanish, please? And here, see if we've got a red button. Yeah, that is the module ID for the Spanish edition, and unfortunately, you need to know that. We do have a piece of work in the pipeline to make SNOMED concepts discoverable, whatever extension they're in, and we hope to complete that in the new year. So there we're asking to have that in Spanish. In the next example, we're asking to filter on heart attack, and that's URL encoded, so that %20 is what a space looks like when it's part of a URL. And then we say, in the final example, let me have everything that's a member of this reference set. There I've specified a count of 10 to come back, so you get the first 10. You see the total that's there, and then there's an offset parameter as well. You'd increment that to work through as many as had been sent back to you. So if I wanted to create a value set, there are a lot of optional fields in there. That's a sort of minimal set that I did for GPS. I put that in the other day. So with the ID of the value set and a compose element, which includes, in this case, a specific constraint to say, give me all the members of the global patient set. And that's using a language called expression constraint language, which I've swapped these slides around a bit because I think it's the best thing in SNOMED at the moment. So I wanted to get to that sooner rather than later. We'll go on to that next. And we can update a put request, just use the same ID again, and it will overwrite anything that's already there, and we can delete with an HTTP delete. So SNOMED has this structure, both in terms of hierarchy and also attributes, which connect between the hierarchies, which means that you could ask queries based on things about information about a concept. So you don't need to necessarily restrict yourself to one hierarchy, or even you wouldn't need to know where you were looking or what these things were. You could say, tell me everything that's related to a lung structure. Find diseases that way without knowing what they are. And that's useful when you're, for example, when you're creating a user interface. SNOMED can seem like a very large and complex thing. 350,000 concepts in there, active concepts in there at the moment. And for a user interface, you can't expose people to that. We need to narrow it down quite a lot. So in this case, we're looking at an assessment. So we'll say, right, I'm only interested in concepts in the assessment subhierarchy, and I start typing. So I'm going to be making use of my filter parameter there, pass that through to my FHIR server, and it will give me a restricted set of values back. CSIRO in Australia have been working with us, and they've written a user interface demo, which we're showing off at the moment. We'll maybe get into this in the exercise section. So that's snomed.org/UI if you want to have a look at it. And that's what we'll maybe do is look at the network tab in the developers tools for that during the exercise section and see the calls that get made. When I'm type ahead into a procedure, then we're restricted to the procedure subhierarchy, so we only see things that are in there, and the filter attribute. The filter parameter restricts those to into that section of SNOMED. So expression constraint language ECL allows us to do analysis. We can say things like, find me patients, or in our case we look at concepts, but you could apply this over patient records as well. Find me patients with any type of diabetes. So you don't need to know what all the types of diabetes are. And in fact, this protects you from things like, if you were to try and do this lexically and look up patient records using the term diabetes, you might find other things like bronze diabetes, which it's not actually a type of diabetes, it's an overdose of iron in your blood. So that clinical underpinning of SNOMED protects you from that, because clinicians have said, no, these are the types of diabetes mellitus, all that work's done for you. And if someone discovers a new type of diabetes, it will slot into here. You wouldn't have to change your query, you wouldn't have to change your subset of what old diabetes you might look for. That will just appear for you in the next edition of SNOMED. So that's working with the ISA subhierarchy. Here in another one, we see a specialization with so I want every type of infectious disease where I have a finding site as some sort of lung structure. And the little hat symbol there will mean everything that's a member of this reference set. Conjoined with some sort of behavior finding. So this is the syntax for ECL. This looks absolutely impenetrable the first 5 or 6 times you see it. After a month of doing this, you'll never look back. You'll never want to see another drop down in a form again. You just type it. Wildcard search there is often fun. The descendant or self operator is the one that we use most of. So we'll say, give me this and everything that's a sort of one of these things. If you start with that one, then the rest will follow. Right, so that was ECL. How am I going to make use of that in FHIR? And one of the neat ways of doing that is through an implicit value set. So I don't need to define a value set. I don't need to upload it to my FHIR server. I could just hit expand with a certain URL and an expression constraint statement, and get a bunch of concepts back. So here I'm saying my ECL is some sort of chronic disease. So I can do that at runtime. And then pros and cons for doing that, which we will maybe talk about during the exercise. Okay. So I can define my value sets in terms of an ECL query. Here was one I was practicing on last night. I wanted my set of caffeine medicinal products. So I've said, give me all medicinal products that have some sort of ingredient of caffeine. And I've also said I want a presentation strength to be present. I've said the star operator there, any sort of presentation strength, and that gets rid of the abstract concepts, because we say, right, I only want the ones where we have a certain number of milligrams available. And the global patient set is also in there, so you can expand that. I think there's 20,000 odd concepts, and which is a lot to return. Or you'd be paging through that for a while, so I can put a filter on that and say, no, just give me everything that has the word heart in it. Now, as the SNOMED International Terminology Servers implemented it, that filter will work through all the descriptions, all the synonyms that are on that concept. So you'll see things being returned that don't have the word heart in them. And that might be surprising, but the word heart will be in that concept somewhere. Okay, so at this point in the presentation, this was when we were going to be starting with ECL, but I thought it was so fun that I wanted to get it out the way, so we're into the last section now. To draw the difference between ICD-9 and between the ICDs and SNOMED, ICD is a classification, so things are sorted into buckets. They're only in one thing at a time, which means they're really great for statistical reporting. Everything will only be in one place, and all your percentages will add up to 100. In SNOMED, because a thing can be more than one type of thing at the same time, when you add up the number of items in a particular sub-hierarchy and then find a count, you'll end up with more than you should have. For example, a colleague of mine was looking at all the concepts in our top-level hierarchies, and he said, well, that's 17 more than we have in all of SNOMED. How did I get here? And it's because we have things, drug-eluting stents are both products and devices at the same time. They exist in two hierarchies. They always trip us up. But SNOMED has that broad scope. It has a specific granularity. It's what you need to store in an electronic health record. You can map to ICD, and there will be some loss of information in that, but that can be done semi-automatically. So what you can and can't do with ICD-10, we can say, for example, J12, viral pneumonia, that yes, this patient has a respiratory disorder, but you can't say if that's a type of infection or not. You can't detect whether it's the lung. You can detect that it's a virus, but if you look at the text there and say it's viral, but you couldn't ask questions like, well, show me all things that have some sort of causative agent of a virus. So when we're working with SNOMED CT, those attributes allow you to ask these questions and say, yes, I have an infection. Show me everything that affects the lung. Show me all respiratory infections that have a virus as a causative agent. Right, final furlong for anyone who's still resisting the metric system. That's 10 chains, I believe, 220 yards. More terminology this week. We have the exercise session here next after the break. Daniel's giving a talk today, 11:55 in Richard. The equivalent talk, is it, Daniel? How to use LOINC. Rob Hausum is talking about the closure operation in Elon tomorrow morning. That's on the second floor. And John Grimes from Cicero is giving a talk on analytics, 11:55 tomorrow. If there was any slide to take a photo of, that's one. Starter guide to SNOMED, the HL7 page on SNOMED, which lists all the properties I was telling you about. Our Snowstorm server, that's open source, free for anyone to download and use. although you will have to get hold of SNOMED CT separately to import into that. The SNOMED CT browser is free to use, and there's also a link there to our Confluence site of the SNOMED on FHIR working group, which meets on a Tuesday. Okay, thank you. Any questions? Yes. Would you like the microphone?
Oh, if you're going to request. Well, there's some practical things regarding the FHIR model and SNOMED CT, like pre and post coordination. Like
Yes.
you have a condition and it's preliminary or confirmed, you can use a code for that in SNOMED.
There are horses for courses.
Yeah.
When SNOMED strays too much into an information model and tries to define this sort of contextual thing or the status codes, then you can run foul of trying to put too much into SNOMED. The information model allows you to lay things out. We don't see the need to use SNOMED codes absolutely everywhere in that case. We are looking at a way to turn FHIR resources into post-coordinated expressions. The difficulty is that you would then expect that to classify properly, and that's ongoing work. But the information model is there, it's laid out, it's useful. I would recommend making use of it. Generally. Post-coordination is a big subject, and I'd be happy to discuss that maybe in the next exercise.
Yeah, because the practical problem is a lot of clients are not modern applications, they are pretty dumb, so you have to do this smart things on the server side. So
Yes.
that's very
Yes,
exciting.
we are actually writing a post-coordinated expression library at the moment, or that's one of the things we've got on our to-do list. We're currently voting on it as a company. Any other questions? Yeah.
This concern translations, so in different languages. I've seen for in German.
German's
What
an
is the
interesting case.
What is the program for Germany, or German translation in general?
Yeah, that's sort of above my pay grade. I understand that there is a German translation of SNOMED, and it is owned by someone, and there are discussions about how we... No?
There's no German translation.
No.
No, it's like 20 years old, and it's
Okay.
the translation of SNOMED too.
Well, that is unfortunate. I hope that situation can be rectified. We're working on the French translation is really gratifying because there's a number of countries who use French, obviously, and they're working together at the moment. So that's really fun to see. I mean, it is an expensive thing to do, and if many countries share that cost, that's really great to see.
Follow-up question: mapping from SNOMED to ICD. Do you have mapping from SNOMED to ICPC, for instance?
I don't know the answer to that.
Okay.
Suspect not. Okay, thanks. Any other questions? How are we doing for time?
There are mappings from ICD WHO to SNOMED.
Yeah, there's also a mapping to RCDO.
Yes, there is an oncology map. Yeah, I've seen that one. Yes.
Is expand on another operation is able to retrieve all the IDs for a given concept, all the hierarchical IDs, the parents' IDs?
Yes, you can do that using ECL. You can use the double angle operator in the other way and say, give me all the ancestors of this concept. Yes.
For some concepts, it may be relevant some numeric value on how much something. For example, if you have high blood pressure,
Right.
you might have very high blood pressure or a little bit high blood pressure. Is that modeled somehow?
We allow for it. We've recently introduced a thing called concrete domains, which is where you can have the target of a relationship being an actual number. And we're going to be using that in the, that's been agreed that we're going to move in that direction. We're going to do that first for medicinal products, so the strengths of drugs will be actual numbers. At the moment, we represent them as concepts, which is not a great solution, but it was what was necessary at the time as a workaround. So in a post-coordinated expression, you'll be able to use a number as the target of a relationship. Okay, are we done? Are we out of time? Okay, right, it's time for coffee. Thank you very much, everyone. Oh, can I take a photo of you because I want to come back next year? And if I say to my boss, I filled the room, then he'll be like, oh, you've got to do that again. Awesome. Okay, thank you. Thank you very much, everyone.